making the player move. All right, so making the player move. So what is this going to look like? We want the player to move at like probably a fixed rate. So when we create a player, we need the player to have like some kind of physics module. The physics module is going to have to be part of this game object. So far, nothing has any kind of like physics whatsoever. They're all just sort of static. And that's a problem. So if we want a physics module, now we have this like this draw system here. And the draw system is basically reaching in to the meshes and then choosing which mesh to grab out based upon this. And then running draw on it, or then using that. I'm thinking we can do something very similar. We could have a physics struct. So then, like the player struct, the player physics can be sort of based upon that, or maybe an instance of the physics. Then we can store that. Maybe store that in a struct, like so we can have like the physics struct, and then player physics maybe is like dynamically added to it. Maybe it's like a very specific type of physics. I'm not really sure how we want to do that. And then we can pass that in to the game object, and based upon the types, we then run that. Is that how we want to do this? Maybe. I can also see us refactoring this to not base the meshes on the types. We could base the meshes off of a draw system. And then that sort of takes care of that. So let's go ahead and let's create, if we're going to use dynamic dispatch, we're going to need a trait. And then we're going to store in the game object sort of like the physics system. So the way I could imagine that is, let's say I had something where I was going to do like physics, and then this is going to be like a box with a dyne, like physics. Like a trait with that. And then the physics would have probably just an update. And then we update it and it figures it out. If there's anything else that we need to pass in, everything is going to need to have that passed in to us. That might be the way to go for this. So for game object, we're gonna store physics sort of system here, which is going to be a box that holds a dynamic physics, something that implements physics. And we're going to have to take that in here. And then store that away. So that makes it happy just to like store this. So let's go ahead and make all these make the compiler happy by actually implementing this. So we need a trait for physics. Let's go ahead and create an entire physics system here. All right, so mod physics. Let's go back into physics. All right, so we're gonna do a pub trait physics. What does that really mean? The only thing I know that we're definitely gonna need is an update. We're gonna take a mute self, and I don't know if we need anything else right now, and I don't even know if we need to return anything. We're just gonna have function update. That's all it is. then we can start implementing what these physics look like. So if I have, let's see, pub struct, this is gonna be the player physics. We already have the location. But it's gonna store a velocity. So we're gonna have a velocity. Now our game object, its location is a vector too. Okay, so our velocity can be a vector too also. Okay, so vector 2 of F32 type. We probably want a speed. Like whatever, well, I mean, our velocity is our speed, really. I mean, maybe this is all we care about. So, because we have our width and our height, those are all stored on the game object itself. So in this case, we have our player physics, we have our velocity, we then want to now implement this physics trait. Well, let's create a new player physics first. So let's actually take in the speed here. And if we know that this is going to come in as an F32, and so we're going to return a player physics that's going to have a velocity new, and the X is going to be the speed, and then a Y is going to be 0.0. And we're also going to want to implement physics for player physics. And then we'll bring in this update. We don't take anything, but you know, we are gonna have to take something. We're gonna have to take in the location from the player, the game object. So the location is gonna have to be a mutable reference to a, well, really just a vector too. Okay, and then in physics, when we update, we're just gonna update our location. So location plus equals self.velocity. And that's it. That's gonna be our update for physics here. Now we're gonna want, so game object is gonna be storing this physics. Let's go ahead and use super. There you go. So now we have the appropriate type spread around. And, oh, you're just yelling at us because we don't implement debug for physics, right? Yeah, physics. I wonder if the trait needs to implement it too. Binary assignment cannot be applied to type reference to mute. Do I have to dereference here? Because you're a vector 2, and you're not a vector 2. Yeah, I do. So dereference to get access to the actual location in memory, as opposed to just the pointer, and then update it. Okay, so you're happy there. How about everything else? Dyne physics doesn't implement debug. Oh, I think the trait needs to implement it too. Is that true? The trait debug is not implemented for Dyne physics plus static, required because of the requirements of this. Does box not? So physics, we have a, oh, derive, okay, so here. Right, so unable to do that. So I think, even though I'm deriving debug for the player physics, is it because it doesn't know what it is? Probably. So I think I have to take away the derive debug for all this this game object, which of course, oh, Dyne physics plus debug? Physics. Oh, also, good morning, physics. Dyne physics plus debug. Oh, okay, I got it. Game object expected trait found derived macro debug. Okay, so it doesn't like that. Isn't debug a trait? I guess it's not. It's a macro. Okay, well that didn't work. I guess so. This is a macro that's applying it. Okay, I guess that makes more sense. It must be a different name. What is the debug trait? Let's go look it up. Okay, so here, this is the macro. So this is the macro, unfortunately. Wait, that. I thought this would like compiler built in. Okay, great, cool. I thought that was gonna show me like what the trait was, but I guess not. I just want the trait debug. Hold on, I don't want to click in there. I want trait. Okay, that's implementing it. Oh, cool. It's just the drive macro that implements it. Awesome. Is there just like a list of traits? Not really. Oh, that's nice. Okay, so how about what implements debug? Does like an F32 implement debug? No, it doesn't. What? Is there anything in the standard library that implements debug on its own? without me having to like do that entire thing. Because I would love to know where it is. It must be a different name, but I don't know where. Like, where in the documentation can I just like look at the list of traits? I think I would hope that they're sort of in its own section. I mean, so that's macros, obviously. Modules for traits? No, I don't see anything like that. Primitive types don't seem to implement debug. Or at least not that I saw over here. I don't know. I don't know how to find that. There's raw trait object. Maybe use core format debug in scope. FMT. Huh, I would figure that might bring that in, but I guess not. Let's try it. So if I do that, Physics doesn't implement debug. Have you implemented there? Do I need to write my own? Do I have to have like no space? No. Let's see. Yeah, so I don't know. It's not the same one, apparently. Another approach would be to force debug onto your physics trait. How would that work? Okay, so if this, interesting, it's not saying that this doesn't work. So physics trait, I can't force it on here. It doesn't allow me to derive it. So how would I add debug on there? Would it just be like, oh, could I do something like impl derive core format? Oh, you're not a trait. Trait foo where foo debug. You're trying to get a Rust playground working? Okay, so trait foo where foo debug. Oh, so like trait physics where physics debug? So I was thinking like you implement a derive for physics. But I guess like maybe I can't do that. Yeah, so it's not in core format. And of course, derive isn't actually a thing. And I could find something else for it. Let's see, is there something in the standard library? Okay, there's standard format debug for physics. And then I have to do dyne. Okay. That added more errors. So you're still very upset. Let's see. But what if I do this? Let's comment you out. Standard format debug is it looks like it's the trait. So standard FMT debug. Okay, so physics doesn't implement debug, even though I'm trying to say that it does, but that's because this physics does not. And if I try to you still say, okay, you don't implement debug. Cannot be formatted because it doesn't. Only auto traits can be used as additional traits in a trait object. So this is where you're suggesting that I could do the trait foo where trait. Okay. So where is that? That's trait physics where physics debug. And this would be so that doesn't fix you. Trait objects without explicit dyne are deprecated. So where dyne. Which doesn't fix you. Oh, but maybe now I can not have you. No, that doesn't fix you because it doesn't implement debug. Oh, and you're unhappy here. Am I missing the function? Do I have to manually add it? Okay. I may, so for right now, I think I'm gonna undo this. Just remove, oh, what? No. Whatever button I clicked, that was wrong. Okay, so we're just gonna implement this, but I'm gonna start removing the debugs. And then physics, if you do get that playground working, I'll be happy to add this back in. But until then, let's go ahead and remove debug from all the things. Okay, so this function takes 7 arguments, but 6 were supplied. So game object new is now also expecting this box physics. So that means we need both a physics for like a static physics and also the player physics. This is not going to have anything in it. I wonder if I can basically just do this. Impl physics. And we're gonna have our update, but we're not gonna do anything with it. So just save that. Then in the main library here, and now we're gonna have to add in, like, figure out which physics do we care about here. So in this case, for the start, it's gonna be a static physics. So for here, so after my type, it's gonna be the physics, and that's a new box. So box, new, we're gonna use player physics and static physics. So start, you're gonna get a static physics, just like that. Trait foo, where self debug. Oh, and physics. You tried to give that. You've been here for a while. Let me make you. How do I? Oh, I think it's this. There you go. Physics, you are now a VIP, so you can post a link. You didn't test with the struct properly, but you hope. All right, let's try that. I'm gonna get this working first, and then we'll go back and try the what is it? The entire dying debug states. Okay, so missed a semicolon there. Okay, so we got the new static physics there. Then this next one, okay, the player. So the player is going to get box new, player physics new. And then our speed. So I believe this is gonna be the game. That's speed. Okay, so happy there. When we create the spike, it's gonna be the, what is this? Static physics. This is the end. And then a for object. All right, no errors. So this should still compile. We should now be able to run update. So we should be able to tell the grid to update now, which I don't believe we have one, do we? So we have this draw method that's not being used. We need a grid. We need an update now. And so in this, we're going to loop through every single game object that we have in the grid and run their update method. So let's first start with the row. So self.cells. We want to turn this into an intermute. Then for, I guess this is going to be the cells. Intermute. Then we want to loop through each cell. And then finally, run the that update method. Now, what are you yelling at us about? You're saying no method update found for game object. Right, because it's not going to be this. It's going to be game object dot physics dot update. No field named physics. So we do have a physics here for this game object. Why don't you see it? I'm adding it in there. Do you need to be public? So we're getting our game object. We currently have to have this physics in here. It shouldn't matter that it's a box or not. It's just saying that it's not even able to find physics. Oh, do I need to dereference it? A field, or is it dereferenced here? I'm seeing that this is okay. So it's a mutable reference to game object. Okay, so that makes a lot of sense. Isn't it saying that you have a tuple? Oh, you're right. I do. Oh, I totally forgot. Thank you. This is basically the ID that we don't care about, and then a game object. There we go. Now, okay, so update takes one argument. It takes the location. So this is going to be the game object. Now this is going to be interesting. Can we do this? Yes, I can. Okay, so perfect. Now if I run this, oh wait, we're not running this function yet. So now we have update. Let's go to our main library. In update, we're going to have the grid update. Apparently I just exited my shell, so that's cool. Cargo run. There we go. And our player is off and running. So that's perfect. Then I want to have the camera follow the player. So every time that we update the grid, we're gonna have to find where the player is and update the location. So now that being said, let's clean this up and then we'll try your thing, physics. So let's see, and game object, width and height is never read. I mean, I guess that's true, but we're gonna need it for collision detection. So I'll just... Okay, unused variable, game object ID, so we'll just go ahead, underscore U. Unused location. Right, for static physics, we don't really care about you. And there we go. So everything else is fine, and our player still runs. We're just not following them with a camera. Okay, perfect. Now, back to what you were suggesting. Trait foo where self debug. Okay, so Let's go back to our game object and derive debug for this. And that's going to say, hey, here's our problem with physics. We need to implement this. So trait foo where self debug. That's in here. So trait physics, is that here? Where self debug. And of course, this has to be the standard FMT debug. All right, so problems. Player physics doesn't implement debug now. Okay, so let's now come into here and derive debug. Static physics doesn't implement this. Hey, there we go. Okay, so if I run this again, everything should be happy. Perfect, perfect. And what this should mean is I should be able to, in primary library, let's go ahead and add it back into the grid. No problems, we'll go to the main library, we'll create the grid, and we'll populate the level. And let's now debug the grid. And that's really cool. We're now able to see everything sort of debugged out, and we're able to see, okay, here's this physics, static physics, which doesn't really have anything in it. How about the player physics? There it is. Here's our player physics, and it's showing us our velocity information. So that's perfect. Physics, that is awesome to have. I like that. Thank you very much. All right, so now we're going to want to have the camera follow the player when the player moves. So what does that mean? We need to query, like, there's a couple things. We could query the grid for the player. Or we could do a little bit of a like an observer, like have the camera observe the player, or the opposite way around, have the player inform the camera. I think that might be the best way to do it. SS Video Game Developer, hello, good morning. So I'm thinking, we're in a threaded situation. Let's go ahead and create a channel and have the player inform the. It's night where you are. Is that? Let's see. Is that Eastern Europe? I don't know. I don't know where that would be. That would be exactly night. Like maybe Australia. But for me, it is 9:40 in the morning. Okay, so when we create the physics, and just for the player physics here, I want to take in a channel. So let's go ahead and for our main library, let's use standard I think it's standard sync, MPSC. I want a synchronous channel. Do I want a synchronous channel or I think it's just a synchronous channel. The Clown Flew, good morning, hello. It is going good so far. We've made really good progress. I think I want a synchronous channel. Then in here, we're gonna create our events. And the channel is gonna be an event essentially. So if we send something over it, it is the event. And that's gonna be like as opposed to a full observer pattern, as it were. So it's and we're gonna get like the send and receive. So let's go ahead and like start this off with let equals sync channel. Ooh, wait. What does that want? Sync channel bound. Sync channel 1. What is the 1? Oh, that's the size. Okay, the channel is an internal buffer in which messages will be queued. Bound specifies the buffer size. When the internal buffer becomes full, future sends will block, waiting for the buffer to open up. Note that a buffer size of 0 is valid, in which case it becomes a rendezvous channel where each send will not return until a rec v is paired with it. So I think 0 is fine here then. Because I'm going to be immediately receiving that. At least I think I am. So if I do that, now we're expecting a sender and receiver. So the send is going to be the this is going to be the event. This is going to be the player moved event. Oh, and I think I have to like send it by a certain amount. So I kind of want a new location, as it were. So this is going to be a. Do I want this to be just like a full vector that I send, or just the X? Probably just the X. So an F32. And then the player. So player moved event send. And you're an F32. All right, what are you upset about? Expected comma. Oh, did I put this here? How do I give what types it's going to be sending? It's unknown type still. Turbofish syntax? There it goes. Okay, so turbofish syntax here. That lets us know, okay, so now we have this event send and event receive. It's a receiver of F32 and a sender of F32. So let's go ahead and we'll do the sender first. So in our physics, when we create a new one here, we're gonna want a, basically it's just gonna be a moved event send, which is, this is going to be the type, the sender. And we're going to send the new X coordinates that we are. So every time that we move and we want to then store this away. and store you right here. And every time that we update our location, we want to now send out what our new X location is going to be. And I think it's .send, and then what that data is, which is going to be this new location .x, and that's it. Now this returns a result with a potential send error. So we're probably going to want to do a custom error out here. So we can open up our errors and we can add in a new custom error. So what is this going to be? Could not send location. And what type of error are you? You're a send error. Which is probably under, let's see. There it is, send error. Oh, do I need, oh, a type argument. I don't even know what type this is. The error contains the data being sent as a payload so it can be recovered. Okay, so this is going to be type F32. So we happen to know could not send location, which is an F32. So then in physics, so our trait here is now going to return now, do I actually care about this? It's just going to return us the error that has like the location that we tried. Maybe in this case, we just don't send and we print out and say, hey, we attempted to send, this didn't really work very well. So maybe we don't like capture this as part of our errors. Maybe instead, we say if let error equals this. Then we want to extract out this send error that has the F32. We can even print line and just print the error. Okay, I think that might be good enough for us. Okay, so then this is us sending out, let's see, function takes 2 arguments. So now we need to pass into the player physics new this moved event send. Where did we create that? So this is in populate level and it's under self as, where did I put that? That's in the main library. Okay, so here's moved event send. We actually need to store this away. Okay, in populate level, we're gonna pass this into here. And then give ownership into here. Because like, we could have many senders, but only one receiver. But I don't care about like actually sending those multiple times. So moved. So this is going to be the player moved. Oh, I need to pull in the sender. Okay, so sender F32. They're going to come down to here and then pass in the player moved event send. So you're happy there. Come back to here. In populate level, we now need to pass that sender in. And there you go. So there's that sender. Mismatch types, expected struct sender, but found sync sender. Okay, so that needs to be a different type of sender. So sync sender. Okay, so sync sender there. It actually says it's sync sender, but I missed it. So then down to populate level, you're actually going to be a sync sender. And then where are you? Oh, so and then a player physics, you're a sync sender. And a sync sender there. Use a move value, player moved event send. I don't want to, let's see, what's happening? In a previous iteration of the loop. So I happen to know that we only have one player, but it doesn't know that. It could be like multiple times here. So I'm thinking that we're not going to be able to build the level with the player in right here. It's a little bit unfortunate, but let's go ahead and remove it from here, which means we also don't need you inside the populate level. That means we're not going to have to loop through the level. So we create the level. You know, pass you in there. We create the level, and then we can go ahead and create the player, pass in player moved event send to here, add the grid, and increment the next object. Can you clone the sender? Oh, I could have cloned the sender, couldn't I? Because there can be multiple of them. Oh, I totally forgot that. Yeah, let's do that. Hold on, back up to here. There you go. Let's clone. I forgot that you can clone the sender. It's the receiver that you can only have one of. All right, no errors. So everything should still work. Obviously, I'm not... Oh, I forgot we still have that debugger going. Okay, so could not send location. Sending a closed channel, that's airing out because I'm not listening for it. So that's clearly a problem. Let's also remove that debug. Okay, so next, we need to receive this. The camera is going to be the one that receives this. Okay, so we're going to have a sync receiver. Is it just a receiver? Yeah, you're just a receiver. That's what it is. So we don't really care about anything else. All right, so when we come in, when we create the new camera, we are going to store this receiver away. So this is going to be the player moved event. Receive is a type receiver that will pass us an F32. And we'll go ahead and just store this away. All right, so we're happy there. We of course need to pass this in, so let's go ahead and do that. Okay, so that fixes that. And then in the camera, we're not using that yet. So when we go ahead and do our updates, do we not have an update anymore? We have a draw. We have a new. I thought I had an update. Okay, so we'll have to have an update here. The camera is going to try to get out of this, and then it's going to update itself. How does this work? Is it... I know it doesn't have to be a thread. Let's just like try it in here and see what happens. If I do player moved event camera.receive dot try rec v, so attempts to return a pending value in its receiver without blocking. This method will never block the caller in order to wait for data to become available. Instead, this will return immediate with a possible option of pending data on the channel. It is useful for a flavor optimistic check before deciding to block on receiver. Okay, so I think I'm going to create an update method. We're not going to return anything. We're going to attempt to receive some data. So let's just start with, and it's going to give us an option, I believe. So if let sum, and this is going to be like whatever it gives us back. I think it's the actual data, so it should be the new location X. Okay, so self dot player moved event receive dot try rec v. Mismatch types, expected enum, result, found an option. Oh, it's a result. So it's an okay. There you go. If it's an okay, we now have the player location X. Then we're going to say self.location.x equals player location X. So if we get this update, we move around. And so every single frame that we update our player, potentially, we're also going to update our grid. So in our, the camera. So here in update, we update the grid, and then we immediately update the camera. There you go. And I think this is going to make the camera now move with the player. Or not. Ooh, that's not... So we don't get any errors, but also we don't get anything happening here too. So that's not ideal. Ooh, it fully crashed. So it's blocking for us. I probably don't want the sync then. I need to force quit. Okay, so maybe not the sync. Yeah, so like it's looking for a sync right at that moment. Okay, I think that was the problem. That was what the problem is I don't want a sync sender. I just want a sender. So let's go ahead and change this to be a sender. So instead of sync channel, we want this to just be a channel. Hold on. Am I not allowed to say what type it is? Oh, probably don't hand it anything. Because it doesn't have a limit. There it is. Okay. Now, your mismatch types and all these other files here. So you're expecting a channel and a sender. That should be fine. Can you not clone now? Oh, it expects a sync sender, and now it's receiving a sender. So I do need to go into the physics and switch you from sync sender to just sender. Okay, no errors. Let's see if this works better. There we go. Okay, so did our player not move? I couldn't tell. The player's like off to the left. Oh, you know what? I need to make sure that we're always like to the left of the player. So when we set our X, we don't want to be to the right of the player. That would be silly. We want to have our player location at X, and then subtract from like whatever our offset is. So that's actually, we need to have whatever offset we are. So I see a couple ways to do it. We have the player tell the camera, I moved by this amount. And then the camera just sort of updates that. That should work, especially like in this specific game. We could get out of sync, which could be hilarious. Here, let's do this. We're gonna do plus equals to the, we're gonna change this from player location to player moved X. And then we are going to go into the physics, and we're not gonna send, okay, so we're gonna move this. Okay, so send, we're not gonna send our new location. We're gonna send the velocity we moved. We're gonna send that. And now our camera should just like move at the same pace as the player. Until apparently the player just disappears. And then we went out of bounds. I think the player went out of bounds. I don't think the camera went out of bounds. But the player just sort of disappearing is less cool. I wonder what's happening there. So the player is fine. We're increasing by a certain amount, just like 1. Is the player teleporting? One thing that we can do is we could limit our movement. So I haven't done this yet, but I think it might be a good time to do this. Let's go down to in our main library for update. Where is it? I think, is it in graphics? Graphics, no. Is it in timer? Check update time. It's in a while loop in your update for, okay, so it wants while timer, check update. Okay, so that's what I want to do. So while, do I have timer? I don't have timer. Let's bring it in. Okay, so while timer, check update time, pass the context, and our target frames per second, and we'll just say that this is 60 frames per second. We don't need that. Then you both, not all three of you, you both happen. So this will limit ourselves to 60 frames per second, and now we need context. Now let's see if we're like weirdly teleporting through some like weird FPS bug. No, okay, so did our player disappear immediately? Oh, it did. Our player disappears instantaneously. All right, so it should be moving. We're moving 16 every, let's see. If we're doing one frame, like we're moving 1 pixel for our location, and so we're increasing by that. We're doing that 60 times per second. Every second we should go 60 frames forward. That shouldn't like increase us by too much. Camera, I don't believe that if I don't have the player have like a velocity. Now, let's go to physics here. Let's just set our speed to be like 0.0. We're not moving. Everything should be fine. And we don't disappear. Okay, that makes sense. If I move really, really, really slowly. So let's bring this back into our speed. When we create the player physics, we're using this player speed, which is off of this game data. So here's the player speed is 6. That might be a little bit too much. Let's turn you down to like, it's like really, really slow to begin with. Okay, so we're fine here. Let's turn it up to 1.0. And let's see if we disappear over time. We do. Did we disappear as soon as we hit the spike? That's what it looks like. We disappeared as soon as we hit the spike. So we're only able to draw one thing at a time within the cell. Is that what I'm seeing? So if we go back to the grid, let's take a look here. In our draw, we're looping through all the rows. We're looping through all this so we get the row, we get the cell, we get all the game objects, and then we draw them. We should be getting the player in here. Let's do a really quick check here. So if let okay, so check to see if it's my type. That's private. We'll have to fix that. And if we get to here, I'm just going to print line. Drawing. So we don't have types in here either. This is temporary, so let's just do a super types, and then my type needs to be public. Wait, why did that not draw at all? Oh, this is drawing in the grid. Ooh. Right, because the grid isn't drawing anything. We're never calling draw in here. The camera is in charge of drawing everything. So we're receiving everything in here. And then going based upon that. Wait, where's draw? Here's draw. So we do our push transform. I wonder if there shouldn't be a problem with the push transform, but I guess there could be. We apply the transformation to the camera. I wonder if it's like disappearing off to the side. And then we draw. So let's verify that we're drawing the player in here. There you go. So if we get the game object and its type is player, then we're gonna say, hey, we're drawing the player. We're still drawing the player, right? It's actually hard to tell. This won't let me. I can't tell if like I'm pressing enter and it's not working. I feel like I almost want to like pass in the ticks so I can like see that it's still going up. Let's do that. Let's pass in the ticks. Actually, we can get that in draw. We can have context right here. We can just do everything we need right here. So for the player, let's grab the ticks. That's off of timer. GGEZ timer dot ticks. Get the number of times. Okay, so ticks. Pass in context. There we go. So we're going to use tick there. It's dead. It's gone. It's just not being drawn anymore. We're not querying it. So what happened? Did I extract it out? When our player is moving, our player is not moving through the grid. That's our problem. We need to remove the player from a cell and place it into the next cell. I completely forgot about that. So every time that we do an update here, we update and we're gonna have to move the player. I'm gonna switch my desk to standing mode because this is, I don't want to sit too much longer, so. Okay, that's what our problem was. We forgot to update our location. So we're gonna want to keep track of where we were before. So let's figure out like our previous. So this is going to be like our previous grid, like our previous index X. All right, so this is going to be the game object dot location dot X. Divided by this like self.cellWidth. And then we're going to convert that into a usize. And do the exact same thing with the Y. With the height. Okay, so we're going to get the previous index X, the previous index Y. We're going to run the update, and then we're going to get the next index X and the next index Y. Okay, so now that we have the previous index and the next indexes, if the previous index is equal to the next index, we're done. We don't need, like, they're still in the same cell, so we're fine. So if you're exactly the same as the next index X, and those both, like, obviously if one of them changes, we still need to change the grid. Okay, so if you are there, then we want to, just an early return. We're done. Otherwise, we're moving forward. So what needs to happen out of here? We need to extract it from the hash map and then put it into a new hash map. So self.cells. It's going to be the previous index X. No, Y first, because we're going down and then across. And so that gives us the hash map itself. So then we want to get out, but I want to take ownership of it too. So there's this get, returns a reference, but I want to take ownership of it. So it's probably not get. Is it remove? Removes the key from the map, returning the value at the key if the key was previously in the map. I think this will give me ownership of it. Okay, so we want to remove. Now the key. So we have access to that with the game object. So game object.id. Now this is an option, so we want to do this as an if-let. Equals you. All right, so now I have access to you. What are you upset about? Oh, expected a reference, not the actual one. That's fine. I'll give you a reference. Cannot borrow self.cells as mutable more than once at a time. Oh no. Okay, so I didn't want to borrow it as mutable again. I want to just use it as the mutable that it was. But I guess the problem in here is we have this cells in here and we're in this game loop right here. So probably what I want to do is create a list of game objects that have moved. We want to create a list of the game objects that have moved, probably by their ID. Yeah, and then like we could store away like the previous index, then the next index, and all that good stuff. So probably here, and we'll just do it after this entire loop is through. So we can have like a let, it's like moves to make. So we'll create a new vector. We'll make this mutable so we can push into it. Now, what are we going to want to push in? We need to know what the previous index x is, so we know where to get it out. And we need to know the next index x to where to put it in. The next index will actually be the game object's like new location. So I could go ahead and skip creating this right now. But we will need to know the previous index x and the previous index y, and then the ID. Oh, and you know what? I do need the next index x and y here, just to determine if we need to do this. That's all. So once we have that, then I want to push into here. Push into this vector some data structure that allows us to know what the previous indexes are, and the next indexes are, and of course the game object ID. So let's actually create this as like an internal struct just for the grid, and it's gonna be private here. So this is gonna be a struct. It's gonna be like a grid move. We're gonna have a previous index x, which is a usize. I might as well store this away. I'm going to do the calculation once. Might as well not have to do it a second time. And then object. Game object ID, which is a U64. I have these all ready, I may not need to do the new on this. It may be pretty easy to just grab these in here. I think they're going to need to be made public too, but let's go ahead and if we reach this point, we want to now game object moves that push in, and we're going to put in a grid move and throw in the previous index X. Okay, there we go. Then we're going to push this in here, and now we have this grid move, this vector of grid moves to make. At the end of this entire loop, here we're going to want to now update the, so like now process these moves. What is that going to look like? We're going to loop through them. That will give us ownership of a grid move here. Then I want to extract out. So okay, so we have a grid move position previous index Y. Previous index X. And then dot remove, and then it's going to be a reference to the grid move dot game object ID. Okay, there we go. Now we're not having to borrow this multiple times. We now have access to our game object. We've removed it from that cell. Let's now add it into the next cell. So what is that going to look like? That's going to be self.cells. Okay, then.insert. The key is going to be the game object ID, and then the value is going to be the full game object, which we have right here. There we go. I think this will work. Let's try it. Oh no, okay, so that didn't work. We still stopped at drawing frame 119. We're running this update. Is this ever happening? This might be something interesting to check. Let's run a debug on the game object. So every time that we do this update, we'll run that. Where's that debug? I think that's in camera. I don't need you. No updates. I broke it. All right. So in physics, actually, I think it's the grid and update. There's a game object physics update. You should be updating there. Oh, did I not update the draw correctly? No, that shouldn't have broken that. Anyway, just put you back. Oh, why did that break it? That should still draw it. Just like normal. Oh, there it goes, okay. So the player still disappears, but that code is not running. So that grid update. So we're not running inside of here. Let's try. Let's try grid move. Which means we need to implement do a debug on you. No updates? Why would you not move? How did that break it? Okay, so clearly, do I have like some weird race condition? Where like sometimes it works and sometimes it doesn't? Yeah, I do. I have some weird thing where the player isn't updating for some reason, sometimes. I think that's what the problem is. And I wonder if it's the channel that I'm sending out. So if I'm sending the channel, because if I don't do that, the player I think moves every time. So what's happening? The player moves, the player updates, and I think the player updates every single frame, even if the player is disappeared. That's what I'm guessing. Let's go to physics here and let's like double check that. Here we're updating our location. We didn't get this error. Let's go ahead and just like show our location being updated. Let's just debug our location. Not happening at all. Okay, so it's not trying. Let's start from the beginning here. Clearly it's being created and put onto the screen, and draw is happening. Here we have our update. Okay, so while timer check time is this happening? Let's put in the we'll just print like what these ticks are. Okay, so the ticks is fine. And here's our player still updating their location. So we know the player exists still. And so that's not a problem. So we know the player is still updating and like, you know, hasn't gone away, which means the player is still in the grid. Now if I get it to not move, that doesn't really help. I want it to not move. Okay, yeah, so it should be going in and running those methods. That should be fine. So this is happening. So we're running self.grid.update. Now I guess, like, is physics updating here when nothing is happening? Like when we don't see anything happening on the screen. Let's check that. Is that the ticks? Did I leave that in by accident? Oh, I think I failed to save. Yeah, physics is not updating here. Okay, so we're getting closer. We run grid update. We loop through the rows, we loop through the cells. Or so we get the rows, we get the cells, we loop through the cells. And then we run this update. And this is supposed to happen every single time. But is it really? Okay, we're getting this running update. Whereas before we just weren't getting anything at all. So it's attempting to run the physics update. And pass in the game object location. So that would be physics. Now wait a second. What are we updating? In the grid, we're running physics update. I think it might be better for us to just run game object.update. Like that. So let's try this. We're going to run game object.update. And then here we're going to call, let's see, mute self.location and send that in. Let's see if this is a little bit better for us. No, okay. So that's not happy. I am running this, right? Okay, so game object update. And I can also like loop through with all of their the traits. And I think I can do this as debug mode. And just like my type out. Oh, that's interesting. It's just start. Only start. Start's the only thing that we ran update for. I mean, clearly everything was on the grid. Like everything is in the level. But why? Okay, like we're running my type. I don't think everything is, well, clearly everything can't be type start. So why would that be freezing it? In this static update, we're not doing anything with this. Let's try this. Can I quit now? Okay, yeah, I can. Okay, so we're running the game object as start, running as not the player. Okay, so that makes a lot of sense. And we know that this is running. What's causing it to get stuck? That's such a, this one is a fascinating bug. So we're telling the game object to update. It's, I believe, actually looping through. So I don't think it's getting stuck on the player. When we started here, it just starts as running game object update as start. It's never running as the player. Like it never gets to the player whatsoever. And I wonder here, okay, so if we loop through, so here we're getting the game object and we're calling update on it. What's, I wonder what's in our cells. Like when it's stuck, I wonder what's in our cells. Let's go ahead and, like, I think we have everything in the appropriate spot. When we add, we figure out where they are and we put them in. Is our query incorrect? Are we not getting out of our query what we think that we are? Let's try this. Let's do a in camera. What is, it's the update, right? We know it's the update. And the query is only for the camera to do the draw. So in grid, let's just run this like on the first update. let's just do a quick debug on self.cells, and then a quick panic, just to quit out right away. Oh, I need to borrow. Okay, so here's our cells. So we have a whole lot of nothing to begin with. And then we move down. Okay, so here's our player. With the player physics, we have our velocity that's 1, and we have our location data. And it's in, its ID is 4. And we have start with an ID of 3. To make this a little bit easier, let's come into the main library and let's target FPS to 1. We're gonna do 1 frame per second, and that way I can do a debug of self-set cells, and then where do we know that they're supposed to be? I think it's supposed to be 3, like position 3 and then 7. So like 7 down, 3 to the right. Let's see what that is. Let's not panic. It's there's nothing in there, but we're moving. So the player is moving in this one. Reminds you of the Chrome dinosaur game. Yeah, it's a little bit like that. Also, Cowtel, hello, good morning. It's been a while since you've been here. Let's see. If I don't have the camera move, I think that works better. What is in here? Okay, so I'm doing a debug of cells 7.3. I should be getting the full hash map of like whatever 7.3 is. So what is that? 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, something like that. But all I'm getting here is just this data. That seems wrong. Like I should be getting the actual hash map in there. Let's drop this down to like 6 and maybe like 4. All right, so it's an empty hash map, and I guess that makes sense for right now. You found a new challenge in Rust. You've been wanting to match anonymously onto any enum you come across in a vector and then compare it with another enum and another vector to check if they're the same type and compare which value it has is bigger. Not sure how you can best do this without needing a gigantic match statement of every possible enum. can you abstract that out into something else? Let me see. Another vector, see if they're the same type and compare which value it has is bigger. I wonder if you can implement comparison, like standard compare or something, or partial compare. Then that might, then you don't have to do quite as much. Yeah, probably a trait, like a implement compare. All right, so this is that wasn't helpful to like look in there. I just got an empty object. Let's okay, so for here we have our game object. We can check to see what type it is. Well, maybe first of all, I'm going to maybe cut this video, like the YouTube part of this out. And then we'll just like continue debugging. But of course, the raw here in stream, we're just gonna keep on working this. So if you wanna see that struggle, then come over here to the stream and watch the highlight. I'm gonna do a marker fix bug. All right, we fixed the bug. It was a bit unfortunate. So what I ended up spending so much time trying to like figure out what had happened. Well, it was because in my grid, as part of my check here, if my previous index is X, so if I did not move the grid, I did a return. I exited out of this function. I exited out of update. So basically it said, hey, the first thing that it found inside of the cell, did you move the grid? Oh, you didn't? Okay, you're done, gone, go away. I don't want to update anybody else. So it just happened to be start was the first thing we found the first time. But then, you know, sometimes it might be the player too. And hash maps don't give you any guarantee of when they're going to come out. So that's the reason why we had that. It wasn't a race condition. It wasn't anything else. It's just I needed to change this to a continue to guarantee that everything is moving. Now, if I run this, our player is now always like moving around. It's always moving forward and everything is good. So we can actually put our player back to the full speed again. So we want like something like 6. This might be a little bit too fast for our player. And oh, this is I believe this is the camera asking for maybe like too much, or like the something going out of bounds. So because we're indexed out of bounds for at the grid, line 69. We can actually go take a look at that. Yeah, it's in the query. So we're asking for like, hey, just give me like, you know, I want based upon this index end. So that's not helpful. We want, so for y index to y index y, we want to restrict this now to the end of that. So index end equals this u size. So if our start is, yeah, so we want to restrict these. So that way the camera can't like move past the right-hand side. Or maybe the camera can, but we just don't bother loading any objects if we can't find any. Like if you're outside of the realm of like, you know, where this is, then you're not going to get anything. So here, index start X, index start Y, that seemed to have been fine so far. But our end X and our end Y, That is a problem. We're just looping through these and assuming that these are good IDs to get. So we need to check to see. Right, so here we're assuming in cells, okay, so this is index Y, X index. We don't want to go into here until we know that these exist for real. So we can do an if and check to see if it's out of bounds. So if our Y index, and I can't remember, does assert return a result or does it just like crash the game? I don't want to crash. I just want to like continue and just like not get anything. So we want if Y index is, now this is a usize. It can never be less than 0, so we don't have to check that. If it's greater than or equal to the, let's see, self.cells dot length, then let's just not return anything. So if Y index is greater than that, or X index is greater than or equal to okay, so if either of these are out of bounds, then let's just continue. And in this case, are we done? I think we can just continue and like attempt to like keep on querying things, but we're not going to actually get anything. Okay, so will that fix our crash there? It does. Our play will continue until the player attempts to go out of bounds of the entire grid, and then that crashes. That's less of a problem because we're going to have the player do some collision detection with the end, and if the player reaches the end, we're done. The game is over. So what we were working on initially is having the player move with the camera following the player. And now we're moving, the players like coming in and out of the grid. So I'd say we're like completely done with the player moving left to right. So let's go ahead. Marker